Today is 3.1, and I'm looking at the last page of the section, and I'm starting to enter data to represent this curve. And sorry, I started the video a little late. 20, 23, 40, 55, 60, 65, 70, and 75. Okay, I'm going to come over, red rover. Uh-oh. And I'm going to enter the next group of numbers, 5, 10, 13. Did I write something goofy? I'll take a look at it. Thank you. 5, 10, 13, 23, 30, 36, 40, coming back down, 35, 30, 20, 10, 4. I need to go up and fix this 2020. No, we don't want 2020. We just wanted 20. Okay, so I entered a whole bunch of data. And I'm going to make this my X and Y list. And that all looks pretty good. Now I'm going to use the stat button again. Stat. And I want to go over to calc. And I want to use quadratic regressions. And a lot of you know these are, in fact, names that you're familiar with. 4 was linear regression, talked about a line. 5 is quadratic. We know the shape of that. 6 is a cubic. That might be one that comes up and bends and does something like that. So if my points look something like that, I might want to do a cubic regression. But in this case, I'm going to do a quadratic regression. And it's all happy. List 1 is L1. Yeah. List 2 is L2. Yeah, we're happy with all of that. Okay. And then hit enter. And nice. I come up with an equation. Y equals, there it is. Y equals negative. Boom, da boom, da boom. All right, so that equation would go on here. It wouldn't hit every point, but it would be pretty close to every single point there was. That's kind of good. And we're going to learn about all the different parts of this. And let's keep going with this. Y equals above the Y equals, excuse me, second Y equals. My apologies. Second Y equals, I get stat plot. And again, I want to plot it with one graph. I don't need multiple graphs. One graph, and I have L1 and L2, which is what I want. I hit enter. I want to do all of the points. So it's on all of the points in blue. I hit enter. I did that and select the type of graphs, which is just the dots, and then graph. Graph can be found. It's the gray button. Oh, here we go. The gray button over here. I hit graph, and I don't have a very good window because you can't see all the points. Okay, so what should it look like? Should be this guy right here. Yeah, no. See how that's pretty close? Not all the points are right on it, but it is in fact pretty close. Now, I'm going to throw this out at you. If I say X is 0, come back to my equation, this term, gone. This term, gone. I'm left with negative 14.285. So my Y, there it is, my Y-intercept would be at negative 14.285. Something we know, okay? Something that we know. This guy has a name. We're going to talk about it a lot, so we might as well name it now. He's called the constant term. This guy over here, the number in front of the x squared, It's called the leading coefficient. Something to be noted about the leading coefficient, and I hope one or two of you or several of you already know, if the leading coefficient is negative, it's what we call concave down. If the leading coefficient is positive, it's concave up. It's concave up. All right, any questions? Any questions? Again, I have my camera in pretty close.
The concave down,
Yeah,
is getting wider or closer? Like if we're graphing it.
it's going to get wider. It's always going
Okay.
to get wider. Yeah, this guy will never get closer. If it does, it's not a function because we may have x values with more than one y value. Good question. Good question. All right, so section 3.1. Here we go. There it is. Whoop, there it is. And a lot of you are going, yeah, I know this. I had this in algebra 2, and I remember some of it. Awesome. Some of you may be remembering a lot of it. Awesomer. But let's see what we have. Quadratic equation is going to be a function that is ax squared plus bx plus c. A cannot equal 0. Because if a was 0, I'd have bx plus c, and that's linear. That doesn't do me any good. Linear doesn't do me any good. All right, here I mentioned a moment ago, parabola opens up if a is greater than 0. That's here. It opens down if a is less than 0. Good. One of the things when I give the eyeball test to keep an eye on to make sure it's going the right way. Okay, so that's an equation in standard form. Okay, and now we're looking at a new one that's called vertex form. And if I learn how to, and I will, change this equation into that equation, it's going to give me a couple of new nice things that'll help me out. And the big one is the vertex. This fella right here, it's called the vertex. Okay. This fella right here is going to be the point HK. And we've seen HK before. The H and K had something to do with my circle way back when. Well, here it is again. The H affects the X. And really, if I wrote this, y equals a, x minus h squared plus k, subtracted k, you'll see how the k is affecting the y. So this is the ordered pair HK, goes over H and down K. So these things, these quadratic equations that we were just looking at, you know, if I come over, oh boy, to the last page, here, you know, up here somewhere is going to be my vertex. It's going to be my high point. I know my A is going to be negative, and so forth. All right. So let's take a look at a couple of problems to put some of that together. Here's my graph. And again, if I was putting it in a calculator, the best way would be y equals x minus 3 squared minus 9. And one of the things I'm just going to have to remember is this. Y equals a, and we'll talk about the a in a little bit, x minus h squared plus k. And if you have me for trig as well, getting to do this right now is going to help you in trig. My h is 3. K is, Bueller?
-9.
Very good, -9. Little hint by the graph here. So we go 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, right there's 9. 9. So I got the vertex. Next thing it wants is, what if x is 0 and y is 0? It wants the intercepts. Well, let's plug 0 in for x. 0 goes in for x, I get -3 squared, which is 9, minus 9 is 0. Oh, how about that? Ta-ta. If I plug 0 in for y, I get 0 equals x minus 3 squared minus 9. 9 equals x minus 3 squared. Let's see, plus or minus 3 equals x minus 3. Because when I take the square root, it becomes plus or minus. And when I add 3, I'm going to get x equals 0 and x equals 6. So yeah, there's that point again, 0 and 6. 0, 0, and here's the point 6, 0. And when I graph it, got a lot of information out of just looking at this guy in vertex form. Here it is, axis of symmetry. It's going to go right down through that point. The axis of symmetry, x equals 3. Because it rotates around that axis. Awesome. Pausing the video. Found my vertex, 2, -1. Plug in 0 for x. I found my y-intercept, -5. Plug 0 in for y. Add 1 to both sides, multiply by -1. And when I go to take the square root, what do I get here? The square root of -1. That's plus or minus I. That means there aren't any, no x-intercepts. There are no x-intercepts. It doesn't cross the x-axis anywhere. My line of symmetry is the line x equals 2. It's my axis of symmetry. And tell me another point that's going to be on this graph. Remember, this is symmetrical. So when I rotate it around that axis, it's going to be symmetrical. I'm going to go 1, 2, 1, 2, and I'm going to make a point right there. Looks like 0, 1, 2, 3, 4, and whatever that is, 4, -5 is also a point. When I graph it, I have a y, but I don't have any x-intercepts. I have symmetry. I have all kind of craziness that this is making me happen. Questions? It's so easy when I explain it, isn't it? Somebody say yes.
Yes.
Yeah. Yeah. All right. Not hearing any questions. As I said before, I'm going to keep going until you stop me. Somebody stop me. Okay. So, this guy right here is in standard form. So my next step now is to learn how to take something in standard form and put it into vertex form. Okay, the vertex form. All right, so here's how I'm going to do it. I'm going to say this becomes y equals 2x squared plus 20x, and I'm going to move the 42 over. You just go on over there by yourself for a little bit. Jiggy with that? Now, if I have a leading coefficient, that's what it's talking about here. If I have it, I'm going to pull it out. Plus 10x plus 42. I'm going to pull it out of these two. I'm going to pull it out of the first one, and I have to pull it out of the middle term as well. Didn't do much except shun 42. You go out there and stand. Pulled out the leading coefficient. Now I'm going to complete the square in the parentheses, because when I get this in vertex form, remember there was something in the parentheses. So this, oh boy, we did completing the square back with circles. What was my 4-word phrase? Oh, lasting impact made on you. Half it, square it. What's half of 10?
5.
Squared.
25.
25. Yeah. What did I really add to this right side? I didn't really just add 25. What did I add? Because if I went up to the line before and I distributed 2x squared plus 20x, looks like I really added 50, didn't I? So if I'm going to add 50 in order to keep balancing the force, may the fourth be with you. Actually, when is, oh no, this is March. That's near Cinco de Mayo. I want to keep balancing on that side, keep balancing the fourth. So this was adding 50 because the 2 out front. So now I need to subtract 50. All right, I got it. I completed the square. And by doing so, I put this in vertex form. Ta-da! I am a math magician, aren't I? Ryan, say yeah. Ryan, are you asleep?
No,
Yeah.
Yeah, you are.
Yeah. Macy, I'm a math magician, aren't I?
Yeah.
Yeah. Are you good so far? I don't know any of you people. Some of you don't ever even talk to me. Oh boy. Okay. I'm going to pause the video as long as somebody reminds me to start it again and see what you can. All right. Let's see what you got. Hopefully you tried it first instead of waiting for me to do it to see if you understand what's going on, because you can't eat a fish if you don't catch the fish. First thing, shun the constant term. Second thing, factor out the leading coefficient. In this case, the leading coefficient is -1. When I pull it out, I get x squared plus 2x. Half it, half of 2 is 1. When I square it, I get 1. What did I really bring into play? Again, -x squared, -2x, -1. So I need to do a +1 here. Again, if this was up there, that would be a -1. So I need to bring in a +1 to balance the force. May the force, y equals -x plus 1 squared plus 4. All right, we can do a lot with this now. I know my vertex is going to be, better write that down more often. Y equals a x minus h squared plus k. My vertex is going to be -1, 4. We like that? I know this guy's opening down because my leading coefficient is negative. So that's something I'm just tucking away. You know, oh boy, I can make a note to self that that's going to open down. If I plug in 0 for x, if I go back to my original equation up here and I plug in 0 for x, I know my y-intercept is going to be 3. 1, 2, 3. I know my vertex was -1, +4. I know this opens down, so those 2 points are helpful quite a bit.
The K should also be -4, I believe.
Y equals a x minus h squared then this is plus K. So yeah, I'm thinking K is positive 4.
Oh, okay.
Yeah,
Oh, yeah, my
But
bad.
is-
Sorry, yeah.
yeah, okay.
Is
No, not a
negative
problem.
one,
Yeah.
negative one supposed to be positive one?
Well, this is X minus H. So good,
Yes,
good
no.
question. So this becomes negative X minus negative 1 squared plus 4. So that when I look at the H, it's actually this negative 1. Yeah, that's something that
Yeah,
I'm
Okay.
glad
right.
you
Yeah.
said it, so I can keep writing it down because of practice. And again, remember, this is similar to the circle. The circle was X minus H squared plus Y minus K squared equals R squared. And it's the X minus H. And it would be, again, if I send this bad boy over, it would be the Y minus K. So keep that tucked away when you're doing your formula. It should help. Put 0 in for Y. 0 equals. Now, I could put 0 in for Y here. I can put 0 in for Y up here. They're both the same equation. So I'm going to put it in the one up above. And I'm going to say to myself, what a wonderful world. I cannot factor this. Signs have to be the same, both negative, and that's not going to work. So I tried, but it didn't work. 0 equals negative X plus 1 squared plus 4. Negative 4 equals negative X plus 1 squared. 4 equals X plus 1 squared. I multiplied both sides by negative 1. Oh, now I remember why this didn't factor, because I didn't write the negative X out front. Maybe it would have factored if I had done that. But anyhow, this is good practice. Take the square root of both sides. Plus or minus 2 equals X plus 1. I'm going to subtract 1. So now I have 2 minus 1 equals X. And I have negative 2 minus 1 equals X. Or 1 and negative 3. There's 1. There's negative 3. And when I graph this, yeah, buddy. Unlike that one before, I have 2 x-intercepts. Earlier I didn't, I had none. They were imaginary. But I have 2. One's here, one's here. I have a y-intercept. I have a vertex. I know it's opening down. Man, am I happy. What were my, this was, I had one at 1 and one of them was at negative 3. Some questions to go along. What is the domain? Well, I can put any real number in because any x is my domain. So the domain is all real numbers. The range is all values less than 4. 4. Y is less than or equal to 4. This would be negative infinity to positive infinity and beyond. Okay, so this guy had 2 intercepts. I can have a graph that opens up that has 2 intercepts. I could have a graph that opens down that has 2 intercepts. Jiggy with that? I could have a graph that opens up that only has 1 intercept, or a graph that opens down that only has 1 x-intercept. So this is 2 x-intercepts types of graph. This is 1 x-intercept. And I had that crazy example where I had imaginaries, and my graph was up in the air, or it was down here, and I had 0 x-intercepts. Okay. Now, when I was doing this and I got 2 x-intercepts, I had a nice square root. Like, if I don't know if you remember back to those problems, but inside of my square root, it was something like 4. And it gave me 2 x-intercepts. This guy was funky because I had a negative in my square root, and it gave me an imaginary. We did a problem like that a little while ago. Well, if it's not positive and it's not negative, what's the only number that's left?
0.
0. So if what's inside of that is a 0, then I know I'm going to have only one intercept. And this guy, we say, touches the x-axis. These guys, they cross the x-axis. That guy's a floaty. Touches, crosses, none. Floaty kind of deal. Okay. So it's all based on what happens in that square root. Well, we've seen that square root before when I worked with solving y equals a x squared plus bx plus c. And if I said this equals 0, what's ax? Well, if I couldn't factor it, what did I do? I said, well, I'm going to solve for x. And again, when I put 0 in for y, that means I'm getting my x-intercept. And then I got something that looked like negative b plus or minus. Whoop, there it is. There's that square root part again. And if that was a nice number, like a positive, ties right back into here, I know it's going to have 2 x-intercepts. If what's inside the square root turns out to be negative, I'm only going to have 1 x-intercept. If it's 0, and if it's negative, I would have no x-intercept. So this guy inside of here, the square root of b squared minus 4ac, that guy was important. Stars, yay, 2 stars, 3 stars. This guy has a name. It's the discriminant. Discriminant. After about 2 syllables, I'm done. But it's called the discriminant. So if I could take a look at this guy alone, and if I said, oh, I know by b squared 4ac, it's going to be greater than 0. I know it's going to cross twice. It's going to cross the x-axis twice. And if that guy inside of there is equal to 0, that's gone. X only has one value, and that's negative b over 2a. And then last but not least, if that's less than 0, that's going to be a negative in there. That's going to be my floating. So this guy, the discriminant, is going to tell me some things about my graph as well. Whoa, look at this. Given a function, quadratic function defined by f of x equals ax squared plus bx plus c, if b squared minus 4ac, again, we call that the discriminant because that's inside that square root. If it's 0, has 1 x-intercept. Greater than 0, 2, less than 0, ain't got none. Whew. I didn't know there was so much stuff going on with this parabola kind of thing. Oh my, it says find the vertex of a parabola by using the vertex formula for the x coordinate is blah, blah, blah. To find the y coordinate, evaluate that. The vertex is given by that. And oh, okay. What the heck does all that mean? Well, let me try to put this in better lingo. Okay. So if I go back to this fella and I said x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so if I do that and take a look at it, I'm going to be able to find the vertex by using just this guy, the negative b over 2a. So not looking at the square root of the discriminant, just this is going to help me with my vertex. And I'll tell you something else. When this guy was 0, I said it had one intercept, and it was one that came down and it touched. And guess what that point was? It was the vertex. It was the vertex, because that became 0, and negative b over 2a, that point right there was the vertex. So what they're saying is this negative b over 2a will always be the x value of the vertex. So let's a quick review. Y equals a x minus h squared plus k. H and k gave me the vertex. That's one way to look at it. A second way to look at it, and again, I'm saying this is h comma k is the vertex. A second way to look at it is assume that discriminant, okay, negative b over 2a. So we're going to say the x equals negative b over 2a. That's my x value. And the y value is going to be, well, I'm going to take that value, whatever it is, and I could find it here if I wanted to, and then I'm going to plug it into my function to get my y value. And we know the y value is always the function of f of x kind of deal. So let's see. Somebody calculate negative b over 2a. So negative b, so I'm going to say x equals negative 48 over 2 times a, which is negative 6. I get 8 as my vertex value, 8. Now I'm going to plug it in to my function. I'm going to plug in 8. So y equals f of 8. Y equals, oh boy, oh boy, oh boy. Let's see, it's negative 3 times blah squared plus 48 times blah minus 165. And my blah that I'm plugging in, I want f of 8. F of 8. Oh, negative 3 times 64 plus 8 times 8 is 64. Carry the 6. 4 times 8 is 32. 384 minus 165. I might actually have to use the calculator. Negative 192 plus 384 minus 165. I'm tired. I tell you, I got up early and made Fosnox. What does that value equal?
27.
27. So my vertex is going to be the point 8, 20. Whoop, I got crooked. 8 comma 27. What do you think about that? Second way to find it. The first way is to put it in vertex form, the h and the k. The second way is to do negative b over 2a and then plug that in to get the y value.
Is there a would there be any like strengths or positives to do it number 2, the second way over the first way, or is this all just a personal preference?
Well, so you see that what we have right now, if I'm going to do it the first way, I have to go through and do all the completing the square and all of that work. The second way, I can just look at the B and the A and plug in, take negative B over 2A and get the X value. So if I'm just finding the vertex, I think the second way would be quicker. If if I want to do it the first way, again, I have to do all the completing the square first. Options. Good question. At the end of his career, Sherlock Holmes retired to a small farm in the country and took up the hobby of beekeeping. Being of an analytical mind, he could not just watch a bee fly from flower to flower. He formulated a mathematical model for the parabolic path the bee follows from flower A to flower B. And the path is this, where X is the distance in inches along the ground, and this is the height. So I wish they would have gone height. And what was this guy? Distance. So when I'm in a certain distance, I'm here. And as I move farther away, I go up in the air and then I come right back down. So here's questions. What is the maximum height the bee reaches as it flies from A to B? So I'm going to take out my magic wand and go, what is the maximum height? Cross out maximum height and write what 6-letter word?
Vertex.
Yep, the vertex. Because that's what it's looking for. What is the vertex? Second thing it wants to know is how far, well, let's not do that. Let's just settle with the vertex. I'm thinking that I don't want to complete the square here. Not thinking I'm going to like that one. So I'm going to use the let X equal negative B over 2A. Again, that was X equals negative B over 2A. And then Y equals, I'm going to plug that bad boy into my function to find the Y value. So I need an X value. Oh boy, this is going to be negative 1.8, excuse me. Yeah, negative 1.8 over 2 times negative 0.03. 1.8 over 0.06, because the negatives are going to cancel and so on and so on. And I get that, and looks like X is going to equal, I'm going to go old school. I'm going to multiply that by 10 and this by 10. Then I'm going to multiply that by 10 together again, and that by 10. Oh, I get 30. So after a distance of 30 inches, how high up was the bee? After a distance of 30 inches, how high up was B? Well, I know the X value right here, 30. I need a Y value. Plug it in. Plug it in. Use a calculator if you want. Negative 0.03 times blah squared plus 1.8 times, oh, I'm down here writing, times 30 minus 24. Oh, my calculator died. You're going to have to do it for me. Do 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 do. Oh, that's nice. That's negative 27. That's 54. Anybody else get 3?
Yep.
Yes,
Nice.
sir.
Nice, nice, nice. Okay, the next question says, how far away from Sherlock are flowers A and B? Here's flower A, here's flower B. If I want to know their distance, I know one of them is going to be less than 30 and one of them is going to be greater than 30. But what are these? In things that we've been talking about up to this point, what are the locations on that graph for A and B? They are the if I have a graph and I go there and there, what are those 2 points?
X-intercepts.
X-intercepts. So if they're the x-intercepts, that means I'm going to take this equation and set it equal to 0. And I might cry a little bit. So I'm going to do this. I'm going to multiply everything by 1, 2 places, which is like multiplying everything by 100. So I'm going to go 0 equals negative 3x squared plus 180x minus 2400. I like that equation a little bit better. In fact, I'm getting excited because I can also do what? Just as much as I multiplied everything by 100, I can also D word.
Divide.
Yeah, I'm going to divide everything by negative 3. So that divided by negative, this is x squared. That's negative 60x. And that is going to be 800. Might be something a little bit easier to work with. In fact, it is. Because I can go back old school, x and x. Signs are the same, both negative. 2 numbers that multiply to give me 800, but add to give me 60. $20 and $40. So x equals 20. X equals 40. Kind of like that because this is 20. It goes up at 30 and back down by 40, and that makes a nice parabola. Questions? No? If you like math, that's kind of fun doing what we just did, especially when it works out and you get the right answer. I totally understand that. All right, so we have all this quadratic information and we're going to keep adding to it. We're going to build this giant inventory of information about the ever popular, exciting quadratics. Section 3.2, determine the end behavior of a polynomial function. Good. The end behavior. Well, we're going to start with some notation as x approaches infinity. Okay, that means my x's are getting bigger and bigger and bigger. 1,000, 2,000, 5,000, 6 million, 20 million, and so on. X approaches negative infinity. We have the term y approaches infinity and y approaches negative infinity. Okay, so if I have any kind of polynomial, My first term is x squared. My first term is x to the fifth. Anything like that. If I start with an come here, come on. If I start with an equation and I say y equals 24x to the fifth, something's going to happen. And what's going to happen is, what is my end behavior? Well, this guy is odd, so we're going to treat him like y equals x cubed. So as long as my largest term in my leading coefficient is odd, if it's odd, it's going to start there and it's going to end up there. So as my x's get bigger, I know it's going to be going that way. As my x's approach positive infinity. If my x's approach negative infinity, it's going to be going down this way. So when I look at this guy, end behavior, I already know how it's going to act as it gets bigger and bigger and bigger. Y equals negative 24x to the fifth. What do you think the end behavior of that's going to be? Again, it's an odd function, comes out as odd, but this time it's not going to act like x cubed. It's going to flip it good. So for this one, it's going to have an end behavior like that. Because if I looked at y equals negative x cubed, its graph is this. Y equals x squared, its graph is this. Or excuse me, x cubed, not negative x cubed. So I have end behavior that's going like this kind of deal. Okay. I know what y equals x squared looks like. So if this power is an even, y equals x to the even, it's going to behave like that. Oh, behave. Y equals negative x squared. We messed with that a little bit. Y equals negative x to the even. It's going to start down that way and end that way. So as x approaches negative infinity, y approaches negative infinity. As x is moving to positive infinity, y approaches negative infinity. And remember, negative infinity is down here. Positive infinity is up there. I didn't do so good. All right, so that's my version of what's here. Mwah, 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 mwah. Ah, check it out. Positive and negative, positive and negative. If it's even, y equals x squared. If it's, so I might even write this, y equals x squared, because I know what that graph looks like. Y equals negative x squared. Y equals x cubed. Y equals negative x cubed. Whew. There's a lot of stuff up there to say that. Determine the end behavior of this function. What's the degree? Well, that's the power of this leading coefficient. This is a fifth degree, so it's going to behave like y equals x cubed here and there. Or I could have drawn my arrows a little more like that. Quick adjust. What's the degree here? Well, I have a bunch of stuff going on. I have a leading coefficient that's negative, but if I wrote this out 3 times, and then I took x plus 1, you know, if I wrote this out 3 more times, and if I multiply them all together, it looks like I'd have something like negative 2x to the fourth as my leading term. And the degree would be 4, which is even, but it would be flipped. So my end behavior should be something like that. Oh, behave. It's awful quiet out there. Even got quieter because somebody got mad and left. 2 people left. Almost done. Let's see if we can, oh boy. Oh boy. Okay, let me turn this way. Identifying zeros and multiplicity of zeros. Tell you what, sports fans, we're going to stop right there today because I want to do one other thing for practice. And I'm going to throw it up here in a minute. Not literally throw it up, but put it up. And there was something in chapter 2 that I want to make sure you're ready for. Okay. What was the hardest thing you remember about chapter 2? All right, it's 2 words. The difference quotient. We'll make sure you're ready for this on the test for chapter 2. And the difference quotient was when I had an X value on a graph, and let's say my graph goes something like this. And I went over a certain distance to here, and I had a new X value. And that distance I went over was H. To this point on the graph. And I wanted to say, what is that average rate of change? Okay, what is that average? Well, this X goes to that Y value, and this X goes over to the Y value f of X plus H. And we said, okay, I understand that. Here's X, there's its Y value. If I move over, don't look at that, don't look at that. If I move over H, this now is whatever that was plus that H, and that's its Y value. Okay, so I'm going to use the slope. The slope was Y minus Y over X minus the X. And we went as far as to say, okay, that was f of X plus H minus f of X over the X is canceled in H. That's where the difference quotient came from. And then if I'd say to you, okay, I want you to apply the difference quotient to this function. And I wrote f of X equaled 2x squared minus 9. And the quickest way we got this was, we said, let's make this f of b equals 2 times b squared minus 9. So that when I put in X plus H, when I put in X plus H here, I put it in there. 2x plus H squared minus 9. That was the left side. The right side would mean be putting in X. So I got 2x squared minus 9 all over H. Then I said there were 2 things that happened. One was all of this ends up canceling. The second was the H canceled. So hopefully if I'm doing this right, that's going to happen. Okay, so now I have 2 times X plus H times X plus H minus 9 minus 2x squared plus 9 all over H. Let's see, this became X squared plus XH plus HH is 2XH plus H squared minus 9 minus 2x squared plus 9. If you practice these, they become really easy. You just have to get over that hump. 2x squared, 4xh, 2h squared minus 9 minus 2x squared plus 9 all over h. Now I'm going through this pretty quick. Remember I said these are both going to cancel. That one's gone and that one's gone. 4xh plus 2h squared over h. I'm going to pull out an h. 4x plus 2h over h. Second thing I said is h will always cancel. 4x plus 2h. And again, this is a building block. Down the road, you're going to use the difference quotient. In the C word, calculus. But here's one that, you know, when you're asked to do the difference quotient on the test, you remember where it came from. Got that graph. The slope was y minus y over this x value minus this x value.
I think we did not have like this kind of problem in Alex homework.
I don't know.
Yeah, we did not have anything like this.
But darn, Alex is pretty smart. But we did do it last chapter, right? Yes. Yes. Okay.